of different materials which are helping us to measure the temperature. The first one is very much known to us, that is liquid property. Like liquid, they are expanding by giving heat, right? Isn't it?
Yes.
So the liquid, their expansion is following one sequence. Like if you are keeping some liquid somewhere in the test tube or any capillary or any other place, and then they expand by the temperature, with the temperature. Like if the temperature rises 5 degrees Celsius, if the expansion of the liquid thread is 1 centimeter, then for 10 degrees Celsius, the liquid thread will expand or increase 2 centimeter. Are you getting me? What I'm saying? Hello? Hello?
Yes, sir.
Yeah. So using this property of liquid, the expansion property with linearity, using this property, we are making the thermometer. Okay, like we have a thermometer of 100 degrees Celsius range, from 0 to 100 degrees Celsius range. Then the length of the thermometer is 10 centimeter. Okay, so each of the centimeter is giving us 10 degree or anything. Like for example, it is giving us 10 degrees Celsius. So if 10 degrees Celsius we are getting for 1 centimeter, then each of the millimeter is giving us 1 degree Celsius, isn't it?
Yes,
Hello.
sir.
So this way we can make the thermometer, and this is called the linearity. You see, there are some terms given here: sensitivity, range, linearity of thermometers. So this property of expansion of liquid with a appropriate or with a particular sequence, this is called linearity of the thermometer. Now not only is happening for liquid, it's also happening for electrical um, components. Like you will get it when we'll discuss the electricity and magnetism, those topics. There is one device that is known as thermistor. Thermistor, uh, from this name we understand it is one kind of resistor whose property changes with the temperature or thermal energy. So what is the property of that resistor? The resistor, if its temperature increases, then its resistance decreases. Okay, so if resistance decreases, that means current will increase. It will give more reading. Are you getting me, everyone? Hello?
Yes, sir.
So am I recording? Yes, I'm also recording. Okay. I will make a table on this, just we are discussing now, and then you'll understand it more and you'll get in organized way. So using this property of thermistor, uh, we can make a thermometer that is called thermistor thermometer, and you also saw it. All of you saw it. That is a digital thermometer. Okay, which one is giving us digital reading? That one is thermistor thermometer. Is it clear? Hello? Yeah, so
Yes, sir.
this here we are using the property of the material, that is the temperature. With temperature its resistance changes. This property we are using uh, to make the thermometer. And there is another thermometer that is called thermocouple thermometer, where we are thermocouple. Here from this name we understand there is something like two. So we are using here two types of metal wares, where the two ends of these two metal wares are placed in a cold container or ice, the container with ice, and another part is kept in the place where we need to measure the temperature. Uh, for that place where we are going to measure the temperature. So the temperature difference, like in one place there is cold in the junction, and another place we have hot in the junction. This difference in temperature makes one EMF. It creates one EMF in the circuit. EMF means cell battery. Have you seen the battery, right? In our house we are using different kinds of toys. There we are using battery. Then we are using battery in the wall clock, right? Uh, those uh, those cell or battery, the energy stored over their per unit charge, that is called EMF. So because of this EMF, this battery is producing a voltage difference, and if there is voltage difference, then electrons can flow through the wires, and thus we are getting the functional, everything functional. So what happens, we are not giving any battery or cell over there, but because of this temperature change in the two junctions, an EMF is produced, and because of this EMF, there is current reading. Okay, the more the temperature gap, we have more EMF, and we see the reading more. So if we see the reading more, we can make a scale here. We can calibrate a scale here with the temperature change and, the EMF production, and thus we can make a thermometer that is called thermocouple thermometer. This thermometer is very special type of thermometer, which is mainly used for industrial purposes, where we have to measure very high temperature and rapidly changing temperature. Okay, is it clear? Hello. So here we used some properties, like here is written, explain how a physical property which varies with temperature may be used for the measurement of temperature, and state examples of such properties. So in our discussion we brought three examples. One is for liquid expansion, uh, for measuring the temperature. Another one is changing resistance with temperature. The other one is production of EMF with temperature change. So these three properties we are using to make the thermometer. And more details will go later. Now I'm writing in table, then you'll understand. This is I don't know. All of you have this book in your house or not? Adrita, you have. Then Farabi also you have this book in your house. Then Mahi, do you have? Mahi might also have this book, the physics book from your school. Which one you are using, Mahi? Physics, a course for O level, Charles Chu. That one, right? I'm showing you from online. We can take the picture. Okay, I can show you it in also video. If I start the video, then I can show you. Here it is. Are you seeing the book? Hello.
Yes, sir.
This book, do you have all of you?
Yes,
No, sir,
sir.
I don't have.
You
Yes.
don't. Mahi, you don't have.
No, sir, I don't have.
Okay, you don't have. No problem. Then Farabi has. Adrita has. Monica, do you have this book?
No, sir.
No, no, you don't have. No problem. Then Mariam, you have.
Yes, sir.
Yeah, Mariam. If Mariam has, then Maimuna also has. Then no problem. Okay, fine. If you don't have, no problem. We are writing from this book. In this book, we have, you see, topic. In this book, we say unit. Huh? Here, unit 8. Huh? From this book, unit 8, temperature. Huh? You go to page 114. Huh? There you will get page 114. There you will get. Huh? If you have the book closer to you, you can bring it, then you can check it.
Okay, sir.
100, 114. So I'm writing here. We can make the ideas here like you give heading this way, physical property, make a table, huh? Please. This is learning outcome A, huh? Learning outcome A. We are doing physical properties. You give the heading physical properties to using physical properties to make thermometer. To make using physical properties to make thermometers. Okay, the first one we said this is liquid. Huh? Liquid, liquid expansion. Huh? Liquid expansion with temperature rise. Where we use it in alcohol thermometer, alcohol thermometer, and mercury thermometer.
Sir, is this for point A?
Yeah, this is for A. All we are writing now for A. Huh? Using physical properties to make thermometers. This one is related to learning outcome A. This heading we wrote. Now with this heading we are writing some information step by step. You write all of them. Okay? Is it clear?
Yes, sir.
Liquid expansion with temperature rise. We get it in alcohol thermometer and mercury in glass thermometer. Huh? Okay, so this one alcohol thermometer we use in lab. Okay, in physics lab laboratory we are using it, and the mercury in glass thermometer we are using in clinical purposes. Okay, all right.
Yes, sir.
Then number two we have second one. You write thermistor thermometer. Huh? Uh, okay, you write the thermistor thermometer. First you write the the resistance, the property right first, the resistance varies with temperature. So this one is happening in thermistor thermometer, thermometer, and this one is digital thermometer, right in bracket, the one we are getting, digital thermometer. And little bit I'm writing also how it's working uh, with uh, temperature rise, because this thing is very new for you, and the first one you understand is very easy for you to understand. With temperature rise, the uh, resistance of the thermistor decreases. As a result, as a result, current increases, which can be can be which can be compared with temperature scale. Compared, better to write linked, which can be uh, linked, which can be linked with temperature scale. Okay, this current, whatever is increasing, like the current reading we are getting, that can be also linked with the temperature rise, what reading we are seeing in the digital thermometer. Okay. There are some more, electronics device action over there, which are used to convert the, current reading into the temperature reading. That is also possible. There are some more, steps or more complex digital instruments are available there. We will have more details later. Huh? Now, number three, that one is uh, the production production of EMF. EMF means electromotive force. Electromotive force, and we can simply say it like voltage. Voltage. So there is little bit difference in between EMF and voltage, but we can understand it now. If you say voltage, if there is voltage, that means there is potential difference and there can be electron flow, right? And that is called electricity. The production of EMF due to temperature difference. Temperature difference between between two junctions between two junctions of wires. Two junctions of wires, iron and copper. You write in bracket. One wire is made from iron, another one is copper. We will show you the diagram also about this, and this one is known as thermocouple thermometer. Thermometer. Okay, so here we got three properties, three physical properties which are used to measure or to measure the temperature or to make the temperature scale or to make the thermometer. So done, all of you are done with writing?
Yes, sir.
Very good. Then Mahi, you are done?
Yes, sir.
Okay, could you please send it? Oh, it's gone. Let me make it in a clear place so that you can take the snap nicely. Okay, it will be better here, right? Okay, here you go. Yeah, you have sent, right, Mahi? Hello, Mahi, have you taken the snap? Yeah,
Yes, sir. I have taken
yeah,
the
yeah,
snap.
yeah. Thank you so much. Then who is not here? Mahi is here. Oh, she told me that she has some works. Yeah, Lamisa told me. Okay, we are done with the first learning outcome. Now I told you that I will show you the thermocouple thermometers so that you can have some pleasant, feelings. Thermo, otherwise, this is new thing for you. Thermocouple thermometer. Yeah, here you go. Thermocouple thermometer. Yes. So this one is a simple diagram. Like from here, we can understand little bit. Like this is iron wire, and this one is copper wire, and there we have the junctions. First junction, and this one is second junction. The cold junction kept at a constant temperature, say 0 degrees Celsius. That is melting ice. And this one is hot junction used to measure the unknown temperature. That means where you are going to measure the temperature. So there might be like here is 1000 degrees Celsius and here is 0 degrees Celsius. So this temperature change is making some EMF or electron flow through these wires, these copper wires, and the reading we are getting here, and the reading we are getting there, that one is also linked with temperature scale. Okay, so like for 1000 degrees Celsius might be there is 10 millivolt. Okay, so 10 millivolt, you can like 1 millivolt for 100 degrees Celsius, that's 0.5 millivolt will be for 50 degrees Celsius. This way we can make the, this one is we know that in our lab also we are using multimeter. Huh? We have voltage reading, current reading, all these things we can measure, and we can set it in millivolt or volt or microvolt according to our need. Huh? So this one is also a meter where we can measure the voltage, and along with this we have also temperature scale written over there, calibrated over there, so that in line with the voltage difference we can also have the temperature reading over there, like the thermistor one. Okay, have you understood this thermocouple thermometer? Hello, Farabi?
Yes.
Yeah, a little bit idea. In practical life, we have actually, this one is a simple diagram to understand, or circuit diagram. And in our daily life, the one we are getting like in real life, the diagram, uh, and the main thing is not like that. It's like the one you got before. You see different, yeah, like this, this one. Okay. So in real life, you will see like that, but how this is working to understand, we are seeing in that schematic diagram. Okay, is it clear, everyone?
Yes, sir.
Yes.
Okay, so we are done with learning outcome A, and as you are done with learning outcome A, we will have some uh, some work done already for D also. You will understand it that now we can go faster, and also some of the things we discussed about linearity, that one also came. In our next class we will have discussion on steam point, ice point, What is steam point, ice point? If you keep the thermometer, like your thermometer you got, that one is not marked yet. Okay, it is empty. Like you got a glass liquid in glass thermometer where there is no temperature reading available. So how we are making the temperature scale over there? That is done by using this ice point and steam point. Like if you keep the thermometer bulb in the melting ice, then you will get some reading over there in the thermometer. You mark with uh, marker, permanent marker over there, and label it 0 degrees Celsius. Then you keep again the thermometer in boiling water. Boiling water, where in which temperature uh, the water boils? Do you know? 100 degrees Celsius. So there you label 100 degrees Celsius when where the liquid level is rising over there, the mercury level is rising there, or alcohol level is rising there. You mark it there 100 degrees Celsius. So you are getting the difference between 100 and 0 degrees Celsius. So this difference is, for example, for this 100 degrees Celsius, you are getting in your ruler, you are getting 10 centimeter. How much? 10 centimeter. So this 10 centimeter is equal to 100 degrees Celsius. Then 1 centimeter is equal to 10 degrees Celsius, right? Isn't it? Yes. Then each of the millimeter is giving you 1 degree Celsius, right? So this way you can mark the whole thermometer, and this process is called calibration of thermometer. The one you got, that is uncalibrated, and the one you made now, that is called calibrated thermometer. The thermometer is calibrated. Is it clear? Hello? So ice point and steam point is helping you to get the thermometer calibrated. Okay, so these two fixed points, uh, these two are very fixed points. The melting ice, if you are keeping the thermometer in melting ice, you will get always 0 degrees Celsius. And if you are keeping the thermometer in boiling water, you will get always 100 degrees Celsius. That's why these two are called fixed points, and the one which is ice point, that is called lower fixed point, and the one steam point, that is called upper fixed point. So in our next class, we will have the definition of them. We will have the application of them with writing, how we are calibrating the thermometer. We will have all discussions in next class and the writings also. Thank you so much, all of you, for your patience, for your cooperations, and we will continue.
Thank you, sir.
Yeah, we will continue from here in our next class on Saturday. Okay, the same time,
Okay.
6:45. Okay, Allah Hafiz. Allah Hafiz, everyone.
Allah Hafiz, sir.